parabolic graph y equals 9 minus x squared, where the base of the arc lies on the x-axis from x equals -3 to x equals 3. Find dimensions of the rectangular window of the maximum area, another key term here, maximum area, that can be constructed inside the arc. The picture is not provided. So based on the graph y equals 9 minus x squared, which is the parabola opens down, okay, the intercept when x is 0, y is 9. And for the x-intercept, for y 0, x can be -3 and +3. And it's 9. And this arc is follow the function y equals 9 minus x squared. We're going to find the dimensions of the rectangular window of the maximum area that's construct inside of the arc. So inside, that means the top left top right ends here will be on the curve y equals 9 minus x squared. Do you have questions on the figure? No. Okay. So the goal is to find dimensions. We're gonna find use x and y again as dimensions. So x and y um, of the rectangle maximum area. So the key term maximum area. So to max the area. So the area gonna be the objective function to maximum the area as a. Now we find dimension x, y. So this can be x multiplied by y. Okay, for the x multiplied by y, let's locate on the picture real quick. The y is straightforward, so y is the vertical measurement here, and the x would be the horizontal. Just to make it um, less complicated, let me use notation instead of the x and y. Just use the length times width. Okay, length times width, and this is the length, and this is the width. Okay, length times width, so the area is length multiplied by width. If we use the width as the y variable and the length, since we drew the picture or the diagram as according to the information, the origin is right in the middle of the picture here, and to the right is measurement by the x value, to the left another x value. So then the length gonna be twice of the x value based on these coordinates. Okay, so this to the right x, to the left -x, which is the same quantity. So put the absolute value here. So the length is 2 times x. Okay, the 2 times x. Since the graph is symmetry, so basically we look at the half of it and multiply by 2. We can see in that way as well. So from the area, we use the length times width, and the length is 2 times x, 2 times x, and the width is the y, based on how we identify the variables. Questions? And the constraint, this the objective is the area. So now we have a as 2x times y. Right now we have area or the objective function based on two the two variables, which are the x and y. Next, we're gonna use the constraint or the condition to see the relationship of the x and y to eliminate one out of the function of the a. Before we move on, do you have question? No. Okay. So to find the relationship of x and y, again, the problem give you based on the graph of the parabola y equals 9 minus x squared. And the point here, see the point y? This is the order, if this measurement to the right here is the x up y, so this is the order pair x comma y on the curve. And this is the order pair negative x comma y on the curve. So x and y, or whatever the order pairs at the top right, top left ends of the rectangle on the curve, that means x and y related based on this function, y equals 9 minus x squared. So 9 minus x squared is the constraint or the condition that shows the relationship of the x and y. As we identify this as a constraint, back to the area function, a is 2x multiplied by y is 9 minus x squared. Okay, so let's see. So after that, we see the function a now in terms of x, all involving x. From the area function based on the x, we can identify the interval of interest, and it should go along with the picture that we drew. As we see this as 2x times 9 minus x squared, the domain, or not the domain, the intercept of the a, or the quantity that make a positive. The area has to be positive, or the least case going to be 0, right? Going to be when x is 0 or greater than 0. So x greater than or equal to 0 here. And this term going to be 9 minus x squared greater than or equal to 0 as well, to make the area non-negative. For 9 minus x squared, we can write as x squared minus 9 less than or equal to 0, and solve this inequality. You factor completely. So x minus 3, x plus 3 less than or equal to 0. Two critical number, negative 3, positive 3, the sign in between or in each interval. So the area or the interval that give the negative sign of this product is between negative 3 and 3. That means with this equation of the A, the restriction of the X, it has to be a negative 3 and positive 3. As you see from the picture that the length, the left end, the right end on the lower part here, it has to be between negative 3 and positive 3. It cannot go outside of the parabola. Are we good? Are we okay to analyze it? Okay. All right. So next we're gonna go with the process to find the critical number. I'm gonna go to the next slide and have more room to work on. So a equals 2x times 9 minus x squared. So we're gonna find the maximum area by looking for the critical number using A prime. This one, you can use a product rule to find the A prime, or you can expand them all out first and then do term by term. Either way, okay, it might be convenient to do term by term. So 9 times 2x to be 18, x minus 2, x to the third, and then find the derivative to be 18 minus 6, x to the second. Okay. Polynomial, easy case. So a prime is 0. Is the case that we can find the critical number. Therefore, the negative 16 equals negative 18. Negative 6x squared equals negative 18. So then x squared equals the value 3. So x equals plus minus square root 3. It can be both negative and positive sign. All right. So with x equals plus minus square root 3, so we have two critical numbers. So x equals square root 3, x equals negative square root 3 as critical values, and the two endpoints would be x equals negative 3, x equals positive 3. Your goal is to find dimensions of the x and y, okay, of the rectangular window of maximum area. So from this, with the interval of interest and the critical values that we found, we're gonna use that to find the area based on those numbers. The maximum one gonna be the one that we are looking for the x. Okay. Okay. For the square root 3, we have 2 square root 3 multiplied by 9 minus square root 3 squared. Square root 3 squared, that's 3, so becomes 2 square root 3 times 6, okay, or 12 square root 3. And the next one here is negative square root 3. 9 minus square root 3 to the negative side to the second is negative 12 square root 3. For the negative 3 is negative 2 times 3, and then 9 minus 3 squared. So this is going to be 0. So the area is 0 here. So at the left end, at the right end would be similar case. So 9 minus 3 squared, so it can be 0. So give the lowest number at the two endpoints. So then the one that's gonna give the the maximum area would be x equals square root 3. X equals square root 3. And based on the picture that we drew, so this square root 3 on the right end, this one is going to be negative square root 3 as the order pair. But the order pair, what the goal is to find the dimensions. That means the length and the width, not just the quantity x or quantity y. So the length, which is the twice of the x, the width is the quantity y. So then the dimension, where did it go? I keep hitting the same number, same option there. So the length, so dimension to give the maximum area would be the length, which is twice times x, which is twice of square root 3, and the width, which is the quantity y, and the y is 9 minus x squared, which is 9 minus square root 3 squared, or comes out to be the value 6. So then the dimension going to be 2 square root 3 multiplied by 6.